Hi, this is group number two, and this is System Analysis and Design. The group members are Cristian Mena Osorio and Mackenzie Taggart, and my person, Hugo Vera Moreira. We are covering the chapter 18, Create, Review, and Coordination Process to increase quality of our current work. The goal in this chapter is to reduce the risk of production changes before they are made. Scott Shekun, CEO and co-founder of GitHub, says pull requests are the mechanism that lets engineers tell others about changes they have pushed to a repository on GitHub. Once a pull request is sent, interested parties can review the set of changes, discuss potential modifications, and push follow-up commits if necessary. So, when I was studying JavaScript in BYU, Idaho, um, we have the opportunity to use the GitHub repository. Um, when I was working in a group member of 2 persons, including myself, and each time that a member of the group made changes on the code or the system, they send those changes to the GitHub repository. So um, the other members can download those changes from the repository, check those new changes to see if they are working properly. If they are working properly, they accept those changes. If those changes was not working, they reject those changes. That is an interesting way how can we understand what is important to the review in this chapter. The 5 steps from control repository management are create branch of master, commit word to branch locally, open a pull request for head or merging, and merge the branch into master after getting review and approval, and deploy master to production. In this first part, we'll see the dangers of changing a program process. In environments with low trust, command and control cultures, the outcomes of this type of changes and testing countermeasures often resulting in increased likelihood that problems will occur again, potentially with even worse outcomes. By changing and testing controls can potentially have the opposite effect that intended at first. And potential danger of overly controlling changes. Traditional changes controls can lead to unintended outcomes, such long lead time, reduced strength, feedback. To avoid that kind of problems, we can apply the following: adding more questions that need to be answers to the change request form, requiring more authorizations, such as one more level of management approval or more stakeholders, requiring more lead time for change approval so that change requests can be properly evaluated. So, as we can see in this graph, if we have more change approval or more uses per review, the performance on IT is increasing, as we can see in this pattern. Um, let's say that we use 5 uses per review or 5 teams. We will have um, a performance of 4 point, I don't know, point four, 4.005 or something like that. But if we have 25 uses per review, we have an IT performance increase of 4.5. That is how it works. Um, Enable coordination and scheduling of process. It is important that there are multiple groups of work on the system that have common dependencies. The changes need to be coordinated to ensure that will not be problem in the process of after it. Sometimes we will need to reschedule our changes when it is a complex organization. When it is a loosely coupled architecture, we can use chat rooms to announce the changes. So it is important the coordination when we are going to do changes, because in that way we can inform to another groups that are related to our area. So it is a way how we can improve the change. Enable peer review of changes. In the development, there is a practice called code review, where we might require engineers to get peer review of their changes. This practice improves the quality of our changes. Guidelines for code review include everyone must have someone to review their changes. Everyone should monitor the commit string of their fellow and define what changes quality as a high risk, and if there is a change that it is too large, it should be split up into smaller changes. Potential danger of doing more manual testing and change freezes. Um, when we use manual testing, we can have a slower, tedious, additional testing takes longer time, deploys are less frequent, and increased deployment batch size. Many other problems that can show when we are working on the system. Um, the thing is that we have to automate all this process um, about testing and change. In other words, the solution that we can use is fully integrate testing in daily work and increase deployment frequency. When we use, let's say that we use a testing or our frequency is weekly, right? We work an entire week making changes, but we make the deployment once a week. It is more difficult um, to fix that problem. So it is important that maybe we can make it in a daily work. Enable pipe programming to improve all our changes. Pair programming, two engineers work together at the same workstation. One person writes the code while the other engineers review the work as it is performed. The benefits of pair programming are skills between devs are transferred, automated tests and implement code can be written simultaneously. Using pair programming can increase error-free code from 70% to 80%. Spreads knowledge through the organization and increase information flow in the team. Okay, I would like to include that it helps to improve the knowledge of the engineers, even for the person who is checking the code and for the person that writes the code. Evaluation the effectiveness of the pull request process. Ryan Tamaiko, CEO and co-founder of GitHub and inventor to the pull request process, they say that there must be sufficient detail on why the change is being made, how the changes was made, and identify any risks and resulting countermeasures. Um, we can evaluate the effectiveness of our peer review process by sampling and examining pull requests, either from the entire population of pull requests or those that are relevant to production incidents. As I said before, the GitHub is one example of how we can check the changes before to deployment into the process. So it is important um, to check what we are going to do with that new suggestion of changes in our code or our system. Fairly could bureaucratic process. Many companies still have long-standing process for a product that require months to navigate. Um, in this example, Target TIP-LARP Technology Enterprise Adoption Process and Lead Architecture Review Board. TIP form filled out to propose new technology, propose and evaluate at lab meetings. On Target 2012, Heather Bigman, Director of Development of Target ENC, discovered that TIP-LARP took too long to get through. TIP-LARP was dismantled, and Lifetime Achievement Award for removing barriers to get technology work done. So, um, in this chapter, we see that it is important to create a review or even create more process to approve any changes. But when it takes a long time, it is a wasting of time. As what we can see in this example, TIP-LARP was dismantled. So we can create more approval process, but at the same time, we have to ensure that each time that a new code is necessary to be checked, that it is important that those check needs to be the fast to avoid the loss of time. So, as a conclusion, integrate practice into our daily work that increase the quality of our changes and reduce the risk of poor deployment outcomes, reducing our reliance on approval process. Create conditions that enable change implements to fully own the quality of their changes. This builds a high trust generative culture. If you have an answer to this question, did you have someone review your change? Do you know who the best person to ask if for changes of this type? Did you do everything to absolutely cool to assure yourself that this change operates into production as designed? Then, if you should be confident implementing your change. In other words, if you have answered to these questions, you have to review, or we have to review our change. This is our presentation. I hope that you enjoyed it. See you from the next time.